Testing, testing. We're about to begin our exercism journey. Let's hope that OBS is not acting up anywhere. And I'm going to be cross-posting this to places. Let's see. Oh, it seems I'm live now. Cool. Just hope it's not buffering too much. Alright, everything seems to be in order. So let's actually start this now. I think it's going to be right there. Alright. Hello, welcome. My name is Miguel Raz. And today I have some exercisms that I want to do in Julia Lang on the Exercism track. So if you've never seen what Exercism is, this is their website. No, it's free. It's exercism.io. And so you basically join a language track. Then if you're somewhat familiar with, let me check. Oh, excellent. Thanks, Chris, for the feedback. So what you do is, let's say that you've never coded anything before in any programming language, or you're very familiar with a given programming language, but not Julia or Rust or Haskell or whatever. You go to this website, and then they have, I don't know, 96 different exercises, 49, 92, 16 for all of these different languages. So if you just, there's going to be an updated version in the future where they have like everything. You'll be able to do it in the browser, but for now there's just a small command line program that they will guide you through all of the installation process. And what happens is that you get these sets of exercises. So you got to do the hello world. The hello world is the first exercise you got to do when you're beginning coding. And so you do the hello world. When every problem comes with what are called, I've solved this one so it's not too interesting, but it's the every time you click on a new problem, it has the name, the description, it says what it expects of the inputs, right? And you're like, oh, this seems like something I could try. So you do this. You see this download your solution, you do copy, and then you flip over to your terminal, right? Let's say that I'm here, and then you do the copy paste, and then it will download it onto your onto a folder. Now I've downloaded a few of these, but let's say that I'm in the I want to go into the Julia track, and then I do the hello world, and then here there's so there's some run tests. That's what it has to so in Julia there's a testing suite that comes integrated baked into the language. So whenever you get any of these exercises, usually what you do is that you try to check out, oh, you know, they probably gave me like some skeleton of what I have to fulfill, and then you're like, oh yeah, this seems like something I should know how to do. And then what you usually do, or what I like to do, is to split up my screen. I'm going to show you in a second. I start up Julia, and then I do the include run file run test.jl file. So I'll do I can verify that I'm in the right folder, and then I will do the include run tests, and then I tab it to autocomplete, and then it will say, oh yeah, great, you did it. And so the next thing that you do to finish up your exercise, if you're super confident, if you don't want to do anything fancy about it, there's this oh yeah, what you have to do is that you do in your shell, in your terminal, you do exercism submit, and then the hello world.jl file or whatever, and then that will push it into the website. And what's really cool about when you push it into the website is that, you know, this is now my solution, right? It's just so you get the hang of it after you do all the installation, and then you're allowed to ask for see that it's just the same thing again. You're allowed to look at community solutions or choose the next exercise, and then not in this one but in other ones you're allowed to ask for mentor feedback. If there was a bit that was too tricky for you, if you wanted to know how to learn to do things a little bit differently, or if you just couldn't get it, as I couldn't get a bunch of them, then you just ask someone to come help you out, right? So that's like the basic. So when it gets really cool is that you get your split screen, you start solving these problems, and then you get the extra exercises, no? And so as you progress, there's some of them that are mandatory for now. There's going to be a new version where all of this changes, and you're supposed to like solve some of them, and then they let you unlock like side exercises, and so they try to like gamify this learning process. If that's your thing, go nuts with it. If it's not, you're allowed to click here on this thing that says switch to practice mode, right? And then that will just let you solve all the possible exercises you want in any order, and you're not bound to like any track progression, linearity or anything, right? So what I'm going to do now is to give you my top 5 tips of what you should or what is really good, or what I found to be a useful workflow for the Julia exercism experience. And so some of that is this, right? Here's my recommendations. So it's a free site to learn about programming languages. If it's not your thing, it's not your thing. If it is, go nuts with it. It's free. And what I think the best aspect that it has is that there's people who volunteer as mentors to give you feedback on your code. There's a lot of like introductory competitive programming problems, and those will help you just like learn the basics or idiomatic ways of using the standard library in your language, and that's pretty cool. What I really would recommend people, if you want to get started with learning Julia this way, is to get comfortable using the REPL, knowing how to get help in the REPL, reading the Julia manual. So it's completely common and normal to just be trying to solve your exercise, and then you don't know what's happening, and so you go here to this is the Julia manual, right? You just Google Julia Lang manual, and then you go into, I don't know, strings, because there's a whole bunch of strings exercises. And then in strings, something's going to come up, and you're like, oh yeah, what is it about string basics? And so you'll go and you read, and it's like, oh, it's like a funky array of chars or something. And then they'll have like useful functions. And so I never knew all the functions that started with this. I like learned them along the way, or a mentor taught me something. No. The other thing that's really useful to get a hang of is this Julia REPL. So the Julia REPL is, you should go install Julia Lang. We're on 1.4 now. It's free. It's online. julialang.org. And so this is the REPL, and you can do print line Hola Mundo, and then that's your hello world. And if you don't know what print line does, you can just, that was a question mark I typed, and you see how it turns into yellow here? That will let you access the doc strings, right? So you can ask it about any function in Julia. You can and so usually they come with examples, and that's really helpful. So like, let's say there's an exercise that asks you to use vertical concatenation, and it'll tell you about that. Or what about, you know, transpose? What is that? All of that funky stuff. It's probably got a doc string somewhere, and it can help you out really well. So one of the other cool things that would very much ease your experience when it comes to learning or doing the exercism track, there's a couple functions that really help out when you're like investigating things to do. So for example, I had no idea how to use dictionaries, right, when I started this Julia track. So if I do methods with and then dict, or rather a type of dict, and then it will tell me, oh my god, no, whoops, let's say methods with a dict, no, methods with, let's say that D is equal to a dict, and then methods with D, methods type of D, and then that will show you all of these, all the possible methods that could apply to that dictionary, right? And what's really cool is that you can try and type, for example, let's say that I want to do transpose. No, if you tab it, it auto-completes it. But if you do tab here, oh my god, that's a lot of them. Let's try reverse. Yeah, reverse is a bit more friendly. If you do the tab inside of parentheses, it will autocomplete with all the known possible types. So that will let you be like, oh, like what functions can I apply to, I don't know, a dictionary, right? And so that will let you very quickly navigate around those. Let's see what other cool recommendation I have. There's also the famous Control Q, right? And probably the edit macro, right? So the Control Q and the edit macro are, you see how whenever you get a stack trace on, let's say that I do reverse 3 and it didn't understand that, you can press 1 and then Control Q, and then that will take you into wherever that function is defined. It didn't work right now because, like, let's say that vim hello world.jl, let's say that I did not define this function well at all. Let's say let's do that. That should not work, right? So if I do include run tests, and then I got a stack trace, so I do 1, and then I do Control Q, and then that will open up my editor specifically to where that error was found. So that lets you get a faster feedback loop going of like what's going on with your code, right? What's another really useful thing to know? There's the edit macro, which is basically, if you ever want to see like, oh, you know, how is a bit set defined? No, what is a bit set? And you just do that, and then it will take you with your editor to wherever it's defined in base. So there's a lot of like poking around Julia internals, right? And so that's a very helpful way to do it. It also applies to your own files. It's not per se necessary to the just to Exercism or to Julia base. It's just wherever it's defined. And using a debugger, right? So I do using debugger, and then I do enter, I don't know, hello, yeah, and then it will take a little bit to compile, and then it will take me into whatever this function is supposed to do. And there's just like 3 or 4 shortcuts where if you learn how to do, right, FR, like what is defined here, if you do a plus, it will show you more lines of code or less lines of code, or you can skip into compiled mode, and all this fun stuff, right? Or you can step into this function and you're like, oh, there's a mistake, and it's like, clearly I'm adding a string and a number. That makes no sense. So that's a very easy way to like make your life easy, or that's a simple way to make your life easier. Learn to use a debugger. You'll probably end up like saving hours on these exercises. I would suggest like just some stuff that I probably should have done at first, so I'm letting you guys know. It's probably a good idea to write down your plan on paper first. I mean, you can try and like just type away until something randomly compiles successfully, but that's not per se like the best way to get this education out of these types of problems. It's probably best to like try and plan it. If you don't have a solution, it's okay. Just like try and poke around the internals, get help, Google it, and then like come back to it. I suggest keeping a diary of all the things that you learn along the way. So this is one of the things that I ended up doing, right? So it's like I didn't know a lot about like dictionary comprehensions, or so this should be lowercase that. And so I should probably not use go-tos, right? It was a nasty exercise, and I just wanted to get rid of it. This get function with dictionaries is really cool. Like, using expressions to be returned within other expressions. Using I/O buffers. I didn't know any of these things when I started out, but now that I've written them down, it's probably a good idea that, or they're more likely to like hang out in my mind for a while. It's totally okay to give up with exercises. I would probably say, actually, as a special case of this, just don't do the Bob exercise. Just skip it completely. It's just so tedious. I hated it. I understand what it's for, but if you don't get it, if you can solve it, just after like an hour, just skip it, or 30 minutes. Just go ahead. Okay, one of the things that probably helps you learn the most with Exercism is start solutions and asking for mentor feedback. So we're going to go back to the site. So let's say that I solved the leap, right? And it didn't really, let's say that this was my first attempt at it, right? It was just a nasty conditional there. And then I was like, oh, you know, my solution is perfect. Nobody could ever improve it. And so what you should do is probably go to look at the community solutions over here, and then you select them by most stars first. And then usually there's somebody who came up with some clean, elegant code, and then you go, you look at it, you try to figure it out, and then you write down all the stuff that you can learn. And then that's one of the best ways that I figured this out, right? So, all right, yep, that's their solution. And then some people are like, ah, yes, this is elegant, or perhaps this could be faster in some other way. No, and it's just, sure, divisible. I didn't know we had a divisible function. And oh, that looks like a lot of functions. That's fine. No, there's not. I don't go there to like hate on people. It's just to see what I can learn. Maybe comment something cool. You can do it as a one-liner. I ended up figuring out it's kind of a nasty one-liner. I wouldn't want to read this kind of code. Can't figure it out. But you know, it passes tests. So that's one way to do it. Probably not the best way, but you know, it's just a starting one. And ask for mentor feedback. So only the ones on the core track you get like you have to wait for a mentor to like give you feedback on, but the other ones you can ask for it. So I would highly suggest that you ask for it. So we're actually going to dive into it right now. We got some comments here from one of our mentors, and they suggested this is the run length encoding problem, right? So I'm gonna let you guys read this for a second while I go for some water. I just want to say, all right, so I'm back. I just want to say one thing before we keep going. With this problem, there's somebody on Julia's Slack mentioned that they're finding this really helpful for beginners. This is something that I probably should have talked about before. So there's a Julia Slack where if you get tired of all of your exercisms, then, or if you're learning, or if you just want to ask questions, you can come to this channel called Help Desk. And Help Desk is the most friendly place for newbies in Julia, and you can ask all your questions, and people are like, what the hello is this? Or how do I do this with my code? And then these Julia gurus, people who know about the language, will just come and help you out, like just for free, just people helping out strangers on the internet. It's pretty cool. We also have a Slack for, there's a channel for Exercism in particular. If you're, no, Scott is a mentor. And so you're welcome to come here and ask your questions. We'll try to get to them in some sort of fashion as a volunteer. And there's also the Zulib chat. It's starting out. You can also ask questions there, I guess. But feel free. I should probably announce that I'm doing this stream thing there. New message. How do I don't know how to do it. There we go. Nope, not that one. Well, I guess someday I'll figure out. Streams. Announcements. Let's do a reply. And we are Brain RPG Twitch. Yep. Streaming now. Walk through. So let's hope they don't bounce mine. No, I'm not allowed to. Streaming now. Announcements, general. Let's go into general. Oh my god, general. Draft. No. Yeah, let's try that. Oh, I can change that here. General. Exercism streaming. All right. So maybe we can get some people to join in on the stream now. All right, great. So, oh yeah, and this is the GitHub repo that I upload my diary to, so that I don't end up losing like 4 days like it happened just like 2 days. So just all the stuff that I go on learning, just like put it somewhere in a file, save it on the internet. Helps you learn in the long run, right? So, all right, I got so run length encoding. We're going to try and do this. I had a lot of problems with this one. I struggled a lot more than I would have wanted to. Oh, the graph C, new topic. There we go. I struggled a lot with this one. So what I really should have done is to try and split this up, this problem into several different functions, put them together, test them, test that the small pieces work, and then like try and like chunk them together. So it's like, oh, that sounds obvious, right? Just like split up a problem, try and solve it piece by piece. But you know, gotta learn this thing. Like you gotta absorb the experience. So what you gotta do is that you gotta get an encoding and decoding scheme going, right? So if you have like several letters, you got to write it as numbers, then letters, and then you got to undo it. So if you see a number, you got to multiply. So there should be 12 W's now, and then just one B. So ones don't get written down, and then one is nor do numbers. So that's one of the like hidden specifications that you got to like sort of figure out with the tests, right? So let's see my first solution. This one was a bit daunting, right? So what I tried to come up with was you should try and count the consecutive number of, like if someone passes you a string, you should try and count like the consecutive number of same characters, right? Like this is going to be one of the building blocks. So if something says count consecutive AAB, then it should start as oh yeah, and it's from a given index, right? Because you want to like keep going. You want to count to a certain point, and then like skip that point after it goes. Skip from that point onwards, right? So if you have X, Y, Z, then the third one is just a Y because there's a space character after it, right? And then the function is a bit easier to start with, right? You do count consecutive. This is the function that will give you that input, while the start count, and then -1. And if you don't run off the end of the string, and a character is equal to this, then assign a new character, no? And then count as many as there are. And this isn't a while loop because you don't know how long you're going to be going for. Like it could be to like the very end of the string, like -1, and then you just got to like keep adding to your counter, right? And then you should return the character that there were multiple instances of. And oh, thanks, Chris, for posting on Zulip. Yeah, sorry that I'm still a bit of a newbie when it comes to Zulip. And it seems cool. I like the LaTeX. I'll get around to it. All right. And so the encode function will use this count consecutive function, right? If the size of the string is less than or equal to 1, just return that, because that's going to be the empty. Oh, that's going to be the empty. Let's try and show this. So this is my basic setup. This is tmux to like split up the screen in this particular like ninja style. Yeah, you can do this with tmux, right? If you just Google it, it's called tmux, right? And you'll be able to like get a lot of productivity with that. I should probably write that down. Tmux and split screen are your friends. So this is why I like that, right? That this is still tmux, right? This switching between these screens is still tmux, right? So this is what I do. I use bat instead of just cat, and then I will do run length encoding and then the run tests, and then this will show me all the tests that I need to pass. So I'll just be like looking at this, and then I have this Julia REPL. Well, I'll do like, oh, you know, what is this encode thing? And then, oh, it doesn't look like I have encode because I am not in that directory right now. So I will switch to that directory. I'm jumping in and out of the shell. Like this is the colon, right? That's what I'm typing. And then that lets me switch from a shell to Julia. And so I can do ls. And so I do this, and I will go now to the, what is it? Run length encoding. Yeah. So if I do include run tests, and then that will, oh, you know, what do you know? It passes. Great. Yeah, because it's already banged my head against the wall for like hours on this one. And then, oh, it doesn't seem like it has a function, it has a doc string. But if I do count, cons, and then I tab it, then yeah, super nice formatted doc string comes here. All my markdown foo is coming to full glory. And then this is why I also like tmux, because I can be here on the vim. What am I doing? Run length encoding, JL, right? So this is usually what I did for like when I got into the groove of this exercism thing. This was the thing that I got the most benefit out of. See, this is here's a silly mistake that I should have fixed. There we go. So, oh, let's try and like resize this a bit. Yeah, that's a bit better, right? So I can look at my, where is this? I can look at my code. I can try it out on my REPL, and then whenever I do a small change, I just change over to it, and I'm like, oh, did that work? Did that work? And so I can see how many tests pass, right? And so, and then if a test doesn't pass, then I'm like, oh, what was that input? No, and then I'll do like, oh, that's a decode that. It's like, oh no, that one works. No, and then what about this one? It's like, oh, that one works too. So, you know, I can try like all my little edge cases here. So it's a really cool playground to like start iterating it too. If you use Atom could also work. Like it's not a text editor thing. It's just like a, yeah, there's many ways to like get a really quick feedback loop on like how to spot where a bug is, no? And so I can do like, oh no, it seems that like my function is like not working well with the with this particular input. So I'll just step into the debugger and be like, oh, why didn't that work? And then you do N to like skip over stuff you don't need. FR to check out what you've defined, and then it's like, oh no, it's like this particular one. It's like I step into it and I'm like, oh, it turns out that when I'm checking if it's a digit or not, I'm like screwing things up or not. So that's sort of the idea. So that's sort of like the workflow that I got going on. If you find something else that works for you, great. No? So we're now gonna go into some of the comments that we got on the last version. So every new version that you like do exercism submit, it like pushes it into this. And so mentors can keep on leaving you comments, and then they'll be like suggesting stuff, and they're like, hey, like you might try doing this instead of that. So we have a very cool mentor here, call him Kane, who's been very, very detailed in how to get the most out of your Julia performance when doing this sort of code. So we're going to try and address some of that now. This is just this one's code cleanup, so it's going to be pretty cool. I like how I've broken the problem down. This looks correct. Well done. Woohoo. Only took like 50 more hours, but we got there. Success. There are a bunch of small things that you could do. Maybe have a go at them and see if you come across anything while you're working on it. Small comments. All right, so that's like the best exercise someone can give you is like, all right, you solved the problem, but is it, you know, how can it be improved? And then you got to like go and scratch your head and figure out, you know, do research. Your doc string contain typesound notation that the code doesn't. All right, so are those type annotations? Oh. Oh yeah. I guess I wanted to make clear what the expected inputs were. I don't know how I feel about this. I don't know, because it feels so clean and pretty to like do this. Ask about, and it says like, oh, this is what it's expecting. But the code doesn't have that. So maybe we should add that to the code. So fs, abstract string, int. All right, that's one down. Let's check if the other one has that. Abstract string, yep. Get char multiplier does not have that either. Abstract string. All right. All right. I think that's good. And then just got to make sure that I didn't break anything, so I do, oh, see? Always got to rerun your tests. So I do abstract, typo, funny. So see, this is like a really easy way to like check that I didn't break anything. So, prefer encode units over size of stir. Now I remember that Scott mentioned that size of was a constant time function. I don't. So here, what's going to happen is that oh my god. So let's do performance notes. 1, where applicable, try to minimize allocations and try and use the linear time algorithm, in essence O of n or less or faster, right? So I say this because apparently size of is a constant time function. In other words, it's O of 1 with ASCII strings. So the rumor says, whereas encode units might not be. I was using length, so let's try this. Prefer size of to length string. infer. This, and then my super ideals. Use benchmark tools package to measure everything in your code. Right? So this part of the fun is just the performance hacking that you can do with Julia. So anytime that I was solving any of these problems, I was trying to figure out how I can make things go faster, because zoom is the best zooms, right? And so I do using benchmark tools, and then I will do, I don't know, this decode, right? So that I will try to do beat time, and so the at beat time will try and be clever about, oh, whoops, I missed something. We'll try and be very clever about how it's like structuring the code, and it'll tell me how many allocations or nanobytes are allocated, and then like how fast the function run. It will run like statistical sampling to like try and minimize the possible noise or like confounding factors. But oh, this is another super tip. If you type something in the REPL and then you press the up arrow, it will try and like look at your history of what was the latest one. So I've been doing a lot of string exercises, and you know the alphabet comes up a lot, so I just have that defined now, right? And so I will just use this as ABC. So on the alphabet, you can see that it's like it's clearly going up in size. It's not constant time, which is, you know, expected, no? But I would just be like trying to like benchmark all these functions and how they're playing together. It's like, oh, can I like squeeze down these allocations, right? So what I'm gonna do is I'm going to first figure out, you know, Colin suggests like, hey, here's like a funky new function that you've never used, and so I'm like, oh, what is this encode units? No? And so we're gonna read this doc to like try and see what is how we can use this in our code, maybe speed it up. Turn the number of code units required to encode a character as UTF-8. This is the number of bytes. So if you don't know, UTF-8 is just like a way to like represent strings in the computer. It's one of the many ways. ASCII is another one, but Julia by default uses UTF-8 for better or worse. This is the number of bytes which will be printed if the character is written to an output string. Or encode unit string, but computed efficiently. So if you use it on a char, it will give you an int. And then return the number of code units in a string. Indices that are inbound such as a string must satisfy 1 less than or equal to I less than or equal to encode units. Not all such indices are valid. They may not be the start of the character. Okay, let's try this. So encode unit. See, there's no examples here, so we could probably make a PR on like getting some examples here. So this is a char. This is a character, character. I don't know. Since they're ASCII, they are probably just 1 byte, it says. So 1 byte is 8 bits. That should be enough. Yeah. Alpha. Yeah. And then in the Julia REPL, you can tab all these like Greek characters and like emoji ones by just doing like slash and then alpha tab to autocomplete, and then, you know, that. And so that one uses 2 bytes because it's probably less efficient. And then what about, you can also do hanky, yeah, and you can tap to autocomplete it. And then that will use for, because emojis are UTF-8, right? And so all emojis are in this UTF-8 thing. So you need more space to like account for all those emojis. So okay, so it looks like this thing will give us what we need. So what about the ABC? And what about size of ABC? Okay, so this is the basics of benchmarking, right? We just try to do this one with the alphabet, and then we try to do encode units. What do you know? They're the same, right? At least in this example. Colin said, so because the alphabet is ASCII, Colin says that prefer encode units over size of string. Otherwise, your code will give the wrong answers for UTF-32. So it's like, all right, I get no performance penalty and on ASCII strings for using size of, and so I should probably prefer to write encode units. So size of, right, and then change in word, and then encode units, and then this one, and that, and then that, and that, and then just, yeah, and for the next, and then period for the vim macro to repeat itself, and then dot, 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 dot. Oh, there we go. It's done. Simple find and replace. And then we do, where's our run tests? Yeah. All right, that runs. So now I just learned something, right? It's probably a good idea to go and write that down. This is how we learn. Write stuff down. 137. Prefer encode units over size of to avoid UTF-32 string problems. Same performance on ASCII characters. Awesome, right? And then I'll usually do a credit to CM Kane. Colin M. Kane, right? Because, you know, he actually spelled it out, and there's credits to all the people that help out along here. Let me check out if anyone's posted anything. Nope, we're good. And let me check the Slack. Slack, yeah, everyone seems to be okay. Sure. Great. And on line 62, you can declare a variable without giving it a value with local. So line 62, offset 63. Set line 62. I think you meant 63. Oh, so maybe what he's suggesting is that we do this. Local, and then that, and then did that break stuff? Yes, it did. Yes, it did. And so, okay, that works. Is it faster? What was the point of this? You can declare a variable without giving it a value. Oh, so I could probably do the, maybe he's suggesting that I do this. Like that? Oh, nice. So I don't need to initialize it to something funky. All right. You can declare variables as local and not assign them. So, and I usually just write where I learned this. Exercism, what is it? Length Encoding. Encoding 139. Line 77. I'd use is empty. Yeah, sure. Sounds like a good idea. This was very much a pattern that I liked It's just like, oh, early return. Like if it doesn't satisfy this condition, just like pass this easy test, right? And I don't know. It's probably not. It's very defensive, right? It's probably not the best idea. So let's try is empty s, and if that returns true, and it will do and return, right? If the first the short circuiting evaluator, the and ampersand will let me check that if something's true, then something else happens. Bam, that works. Nice, passes tests. So good for me. Good enough for me. And up. Yeah, looks like it. Line 94, 96. If you move the I plus 1 into the first branch, then you don't need continue, which I personally think is less confusing. Yes, continues are not a good idea. They're a code smell. Into the first branch. Let's try that. Bam, it works. Great. Code is cleaner. All right, I'm gonna go for some water. I'm getting really thirsty, so, and then we're gonna do one last pass through this, and then try and go over the entirety of the code. All right, be right back. Oh wait, I'm using the wrong mug. I have some water right here. Think you passed me? All right, just gonna check Slack. Yep, that's me. I'm still alive. All right, so we can try this. You can try. Oh, that's another one that we can. Is empty stir. Right. All right. So docstring count consecutive. Counts the number of identical characters in a given string, starting from index start. Examples. Starting from index start. That doesn't sound right. I should count consecutive A, B, 3. Yeah, that should be 1. Whoops. Or rather, let's try this like from 1, it should be 3. Whoops, had an error in my docstring. So if you're actually gonna like incorporate docstrings into like any cool projects you do, there's doc tests that can go into these, and so they will actually try and run that code, and they will make sure that that code passes. So clever people have come up with that solution so that you don't have to, and it's probably a good idea to like make sure that your functions and your docs don't get out of sync, just like what happened to me here. So start is greater than encode units. Turn out of bounds on the string length. Yeah, I'm checking that nothing fishy happens. Don't run off the end. What is this? Do I even need this conditional? Nope. Turns out I needed it. Why did I need that conditional? So any time that I really need to include something about the conditional, I try to like put a docstring in it, because I'm trying to like write this so that if in 50 years I need to like remember what this code did. It's not too hard on myself. So don't run off the end, and then let's see, check that previous car is equal to current one. Yeah, so you're trying to see if they match, then you keep going. If they match, you keep going. If they match, you keep going. Chung, 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 chung. And you add one to the counter. All right, yeah, that makes sense. Cool. I'm smart. Nice. So, all right, next function. If it's not empty, to encode it, you check if it's empty, you start a buffer. Oh, this is one of the big tips. I should probably write that down. I could write a Drake meme on this one, but it's performance notes. Don't use the string and then equal to string 2 method of building up strings. Way too slow. So this actually does a whole bunch of allocations underneath that is just not a good idea. What I'm talking about is like if you ever do like this. So ABC times is how you concatenate strings in Julia, how you like put them together. This is the same as ABCDEF, but super allocating. it does a lot of that. So instead do this. So you write something called an IO buffer. Then you write to the buffer your char, or you write something like string foo bar, right? And then when you're done, after all the processing, to return it, you just do string take IO, and then that will return the string, and then that minimizes a whole bunch of allocations. And so that's probably like the most that's one of the performant ways to deal with strings, is like to not be like constantly multiplying strings together, is to remember to use these IO buffers and then this string function, and then write to that IO, and then take it at the end and call it a string. That's one of the easy performance boosts you can figure out if you're using strings. All right, then so far so good. We're still reviewing code. While I is less than the size of the string, this is to encode it. Assign that car value. I'm gonna sit down a bit. Assign that car value. Get the car and the count. And then if the count is equal to 1, this is the special case that came in the spec that you got to read the problem for. Read the problem thoroughly. Then if it's true, if it's only 1, just write the character by itself. You don't need to write a 1. That's inefficient. If it's not true, then you make a string of the count and the car, and then run that until the end of the string, and then do the fancy trick to get the string back from your buffer, and then you're golden. Because this is the last value calculated, Julia will return that as the answer, and then that should pass tests. Get car multiplier. Get car multiplier. Do those doc tests pass. Get car multiplier 134, and then that comes out, and then 10A3B. So I wrote this doc test because it was one of the cases that was like killing my code that I couldn't pass. That 0 there, you gotta handle it a bit. If you don't have your logic down, it's tight. It's gonna screw up your code. So get car multiplier, the sum is equal to 0. I start a certain index. The offset is 1. I declare car as local. For I and then code unit string, assign that car. If it's a digit, and then this is a really fancy way of like adding up a given something in a base, right? So this is in base 10. So every time that if you're reading it from left to right, then every time you're multiplying something, like the last one is only going to be multiplied by 0. Is not going to be multiplied by 10, but the second to last one will be multiplied by 10 once, and the previous one will be multiplied by 10 twice, and then that's how you get the powers of 10. But you can substitute this as by any digit in any base, and then that will give you the digit represented in the number represented in that base. So, and then this trick, this one Scott also taught me. You can subtract cars from one another, right? Cars, chars. I don't know how to do it, but if you do AB minus right, no, let's do, oh my god, B minus C. Does that work? Minus A. There we go. So that's 1, right? And so what you can do is that if you have, like, let's say 6 and then minus 0, that will give you the number 6. So this is way faster than trying to do parse int 6, right? Yeah, actually, let's benchmark that, and let's add that. It's the performance notes. Don't avoid try to avoid using parse int string. Try these instead. Something is a digit, is digit, or this char, yep. Something is a letter. You can do is letter, but then that will be slower for things that you know to be only ASCII, or a char, and then Z, an uppercase equivalent, and then maybe I should have like done this here. Get digits from strings. Use the, I think it's called it should be called the barycentric formula. It just means that like you start at a point and then you like add or subtract depending how far along you are. But it's just a fancy math name. If you don't know about it, don't worry about it. So it's the A minus, and then char minus 0. What did I write? Char minus 0. Yes. Sum is equal to sum times 10 plus, what is this even? Yeah, just the char. And then since you're playing with ASCII only, then that's like a really, really, really fast way to get it. Unless we're like SIMDing stuff, but we're not gonna get to that today. Yeah. And so let's try and benchmark this. So foo is going to take my, let's call it ASCII digit, is you're going to feed it a char, and it's equal to the char minus 0. And then we're going to do a ASCII parse. So it's going to be a char, and then it's going to be parse to int the char, right? And then we're going to do b time ASCII digit, and then we're going to do 9. So that's basically instant. But if we do ASCII parse, we're going to get, all right, that's supposed to be way faster. But it does make a difference with strings, right? If I try to do ASCII parse 134, now that's got some nanoseconds on it, right? So let's try 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, sure. 55 nanoseconds in allocations. All right, but if I do function fast parse, I don't know, string, and I try to implement this for I in, let's just be bold, fast parse string, and then we're going to do sum of the I don't know how to call the previous state. I'm trying to be too fancy here. Function fast parse string, and then for I in 1 through encode units string. Oops. And then I can use the alt enter to like add an enter into my REPL. I can do sum equals 0, and then sum is equal to sum times 10 plus I minus 0, and bad spacing, but who cares, just for benchmarking. So if I have fast parsing, that one was that, and then if I do fast parse, oh wow, that's not cool. No method matching int minus car. All right, let's try and do that again. That's a car. Oh, because it's got to be something like that, no? There we go. Shaved off those nanoseconds. All right. Yeah. Oh, woo. Yeah, so it's like 50% faster. Not really, but should work. All right. Where were we? All right, so this was like this has been my feedback loop the entire time I've been on Exercism. It's just like get nerd sniped into benchmarking like how fast the function is, and just like go write some like non-reusable code, and then just be like, all right, this thing is faster. I know now more. I'm a better nerd. If it is not a digit, write that chart buffer. If it is a digit, get the digit right there. Skip that many characters. I think I can. I think I don't need that anymore. looks good. All right. Where's my tests? Great, works. So I'm happy with this now. See if there's any final comments from Colin we can address. There's an extra comma there. Don't think this needs to be capitalized. This is just like the very last details. I think, yeah, it's just done. Exercism, submit, and then run length encoding, JL, and then ta-da, it should work. So now if we go to the site and we refresh, then it says, oh, what do you know? There's like a new solution here. And you're like, yes, thank you. All right, so I think we're done with that. Now Scrabble score. Oh yeah, by the way, this is a dark skin on the Exercism website. I use this plugin called Dark Reader because I just think that everything by default should be dark mode. But that's just me. All right. Mentors left you comment. So, oh, I'm gonna let you guys read the instructions, and then I'm gonna come back to and we'll talk about it. Feel free to skip ahead in the video, otherwise. All right. We're back. So, you're given a bunch of letters, and those letters correspond to a certain value. And so, if someone gives you a word or a string, then you should be able to say this was the score of it on Scrabble, right? So, think about it, pause the video for a second, and then I'm going to spoil the at least a couple of ways to do this in like 10 seconds. All right, so there's at least one classical answer, and that's to use a dictionary, right? So let's go to, so this is my setup for when I change. I am doing the Scrabble score. Yes, so I am in Scrabble score, JL, and then I flip around my my windows, and I just change into the directory that's supposed to be. All right, we're good. All right. So I came up, so you're seeing the end product of what I came up with, right? My solution, my first solution was probably the first one that you would write if you're once you've like poked around the standard library or somebody that knows about computer science. SAS clone. Yes, we're gonna talk about performance in dictionaries in general. If you're going for like absolute performance, because dictionaries have to like have to hash the input, they're not gonna be as fast, but they can be still like it depends on your use case, right? So we're gonna squeeze some performance into this one. Not the absolute best, but you know, pretty respectable one. And there's even like some code to benchmark it. So if this is Julia, right? You want to declare like global variables constant if you can, right? So when this code runs, it says like, oh, this will not change. So just any compiler will just like throw performance out the window whenever you say that something's global. Like it just, there's nothing that can be like reasoned about because it might change at any moment. And if something can change at any moment, the compiler just says, I'm not going to touch that. So it just opts out of all optimizations and it makes your code slow. But if you write a const, I'm going to see some tricks on writing things const later, then it just works. So some other people had some really clever solutions on like how to write this in a like more clever fashion. I just like used Vim and copy paste, and I don't know, 5 minutes of my life I'll never get back. RIP. So this was my first answer, right? It was just, all right, if you get a string that's empty, just return 0. Otherwise, just try and accumulate stuff into the sum. This is a very recurring pattern in the Exercism exercises. You start with an accumulator, and then you like filter it with some logic, and then at the end you produce like some result. This is very much like there are types of exercises, right? So it's very much like start with an initial variable, and then like do some filtering, do some ifs on your input, and then otherwise and add it to some accumulator, and then return that. So this is you were right. Hello, Cyan. This is just the dictionary approach, right? We're just gonna do we check if the lowercase of the character that they give me in the string, right? Because this for is like iterating over the string, smart like that. If it's not in that, it just continues. It just says like, there was a space or something or a period. I don't care. It just like doesn't add to your Scrabble score. And if we're just adding to something, it doesn't really matter. No, and then you continue. And otherwise, you just update your sum. This means that you will take your sum and add the previous value and then the new value of dict lowercase ch into it. But this is quite inefficient. You know, Scott came in and he was like, hey, you know, just dicts are not your friends performance-wise. So Scott mentioned something that I didn't really like notice in the first time. Like, these are really small values. All these values fit inside a very compact vector of like int 8s, right? You don't need more than 8 bits to represent this number. It goes up to like 10, no? Like the ultimate performance winner would probably be to like squash all these into like bit vectors, but I was not ready to like try that. So I have no idea how to like build that easily. So he's like, the first line of score is not necessary, get rid of it. You're doing this comparison twice, this lowercasing, no. Don't use the continue, this just adds like one more control flow, just skip it, no. And then try to assign the lowercase first, because otherwise you're doing like something that might be an expensive computation twice, right? So this is like my improved version. You see how I like changed from iteration 1 to iteration 2? This is a new version, right? And I came up with the vector version with uint8s, which seem to be just a little smidge faster than the other one. And then this one, which is the score. So there's the score 1 with an array, score 2, and then with constant dicts and constant scores, right? And then the third one, which is like the fancy one with like a generator, right? And so, and then Scott gave us some comments, but we're just gonna benchmark this for now and to see what's up, and then we're gonna get to Scott's comments. Because, all right, so it passes tests, and then we're gonna use our old friend, the ABCD, the alphabet. Yeah, that's what that's called. And then we're going to do b time score ABC. That, don't worry about that $sign. It's useful for something that just has to do with macros. Just if you're benchmarking, remember to use that. No? So that's score 1 with a, if you're just using a straight up vector of ints, that's constant. And if you're using a dictionary, that's going to be quite a bit slower. So it's almost twice as slow, right? And then if you do score 3, this one's a funky one because it comes up as a car, right? Doesn't allocate, but I'm pretty sure that I should change that function because int. Oh, wow. So we had our runner-up. Yeah, so Sask alone, that should answer your question on like speed. No, it's like if you, so this is why is this a classic like case of like when to use a dictionary? You just declare your dictionary, it's a car to int, you just write down like the association or the pair, it's just like the A goes to a 1, the B goes to a 3, so on and so forth. And then you use like one of these easy patterns where you just look at the dictionary and then you look into that key as if it was like sort of an array and then just like add it to the sum. So it's classic dictionary lookup example. And if you know, if this didn't fit into a compact vector, if there was like a lot more entries and like going to get them was a lot more expensive, then you might consider using a dictionary, right? But you know, vectors are very fast a lot of the time. All right, so now that we did take the time to do that, Scott has some recommendations on how to squeeze a little bit of more performance out of this. In version 1, if you're really struggling for max performance, you know the character set is limited to ASCII, which would not be true for some international scripts. You can speed things up by not using the lowercase function. All right, so we're gonna write with only ASCII, right? So we're going to write this right score ASCII, and then we're going to do if that, else if A is there, char is there. Oh, by the way, remember how I was using the lowercase, I was calculating the lowercase twice in the previous one? I would do like first check in the if the lowercase fits, and then like lowercase it and then pass it into this lookup. If you cache it first, by caching I mean saving it to the car variable, then it will be a bit, or at least my benchmarking of it will show that it's faster code. So else if this is like so, then a all right, let's try that. And then we had score 1, and then we have score ASCII. What do you know? It's faster, right? Because it's just ASCII, and it should get the right answer. Actually, we're going to try that by writing score 0. And then delete end. Boom, that was fast. Yep, that works. So that should make Scott happy. I think score 3 is incorrect because the if part only allows A through C, not A through C. I like the approach of using sum, which is highly optimized, but this is a fairly complex way of doing it that not everyone will understand. Instead of that, what about writing a very small function that simply returns the score and then using that with sum? In essence, something like if this, then return that. Can you try it like that and then post your benchmarking? Sure, we're going to try it. So yeah, let's try and break apart that function, right? Score, oh, there we go. And then I can do that. Score 4. Yeah, thanks, Sion. It's not that bad. Oh yeah, we use our small, what was that function? Score abstract. Score sum or score calc. Abstract car, and then that is A C. If it's there, return the scores table. Otherwise, return 0. Yeah. Scores table. And then we add this +1 because it like rescales everything down to 0. So we need to like bump up the index because Julie is 1 based. Oh, whoops. Hello. There we go. Ah. So because the if part only allows A through C, not A through Z. Oh, what if we did this? If that is true, do that. Else if there's probably like a way that I can chain those operators, those ternary operators, those question marks, but this is just easier. A bit more clear. You don't have to be a ninja to get this one, and you gotta like sort of stress yourself out. So I'll always write for the U that might be like super like not fully woken up, maybe hungover when you're watching this, rereading your code. Gotta take care of future you. So all right, so this is where we do sum I for I n score calc. Nope, I gotta do score calc. Oh, and I gotta do, let's try this. Let's try the propagate inbounds. Maybe we need to do that. Score calc of car for car in string. Let's try that. So that passes. If else is good. Yeah, if else, you know, keeping your code simple has its charm. Score 4, right? Score 4. This has to be an int. So that works. Let's see if we can crank up the speed on this function, because it might not be, it might be like not, it might be doing bounce checks. So we're gonna see if we can get rid of those. Propagate inbounds. Inbounds, for those of you that don't know, oh my god, inbounds is a macro that will, so Julia is a safe language by default, but you can turn it off if you really need those zooms. So what we do is we just annotate our code with inbounds, where we are absolutely sure that nothing bad will ever happen and we will never access anything outside of the given memory, and then that will usually let us get rid of bounce checking, and that should run faster. So it was at like 194. Yeah, see, it got rid of quite a bit. It got rid of like a few nanoseconds. So that versus that. All right. Yeah. So, and the way to really check this is to do code LLVM score for ABC, and then look at the generated code, right? And then if there's a whole bunch of, see, there's your MapReduce, Sion, right? It's definitely compiling down to that. And let's see where there's check.bit is top. I don't know a lot of assembly or like LLVM intermediate representation, which is like this super hard thing that we're looking at right now. I'm just trying to see if there's any words that look like check bounds or bounds checks, stuff like that. If there's not, then you can be like, all right, I'm fairly confident, or like, I'm somewhat confident that that's not happening. And it looks like it's not. Versus, and this is, we're going to try this without the inbounds. So, right? Run tests, and then b times score for, or yeah, that's the one. Reduce, mapfold, bitcast, header space. So somebody who actually knew what they were looking at, they would be able to say like, oh yes, you see this very pointer that it's looking at. That's a bounce check, and that's really going to slow down your code in a tight loop. And I am not that compiler guru yet, so I'm just going to say that if I do score 4 without an inbounds, it gets 193. 190, let's call it 194 nanoseconds, 0 allocs. And then, nope, can't avoid that. Oh, what? 184 nanoseconds without inbounds. Might actually just be like measurement error. Maybe it's just like the maybe it's just a branch predictor. You know, 185. So let's write that down. Scoreboard. 1 score. I don't know what it did. Score 2. Score 3. and then score 4. And so let's do this. Nope, not the right one. Score 155 nanoseconds. $263 nanoseconds. $204 nanoseconds, and then score 4. 105 nanoseconds. I'll put 87. No allocations on any of these, so we're going to do that and then write this. Boop, 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 boop. All right, this looks good. Submit, and that was Scrabble score. All right. All right, and so yep. And the stream. Check out the new solution. But so one of the possible things that Exercism could do better is that you could like jump between versions a bit easier to, or like between versions of the code, because this one like you like the comment history for the new one like is you gotta like flip over to the new one, and then you don't have like access to the comments unless you like click onto the other tab, so you lose that whenever you're like jumping between like versions of your code. So there's probably like some easy fix for how to do the, or have a better interaction with the mentors and like be able to like look at their comments throughout the version submission history. This one's the robot name. I think this one is complete, and it's one of the last ones, and I don't think I'm going to talk about this one now. I'm just going to mark it as completed. Yay. And then the mentor Colin just said, hey, this is really cool. And then I highly suggest that you go and look at other people, like look at this really cool solution that someone came up with. No? You go to community solutions, and then you like click the stars, and then this person just I knew this was possible. I didn't know that you could do this. This was neat, right? You can use a generator. The history should be accessible. Yeah, the history is accessible, but like whenever I flip to a new version of the code that I've submitted, like I lose the comments, no, from like the old ones. So I want to be able to like look at the old comments and like, I don't know. There's probably, I don't know if I'm just griping, but I feel like there could be like an easier way to like switch between the versions of your code without losing the comments history. Like you could do that separately or in parallel windows or something. All right, so you can, this is a really nifty one. Like you use a generator, right, on the key value pairs of a dictionary with 2 for loops, and then you lowercase your input. Now actually, Joshua, my man here, is using the lowercase and broadcasting it to all the letters. So that's going to allocate once. But if you just do lowercase on this letter, you can get rid of the allocations on that one, just as Colin mentions here, and that's really nifty, no? And I was like, oh my God, you know, exploding brain. This guy's on a whole nother level. So if you go and look at the solutions that other people have contributed, you learn these kinds of like tricks to get around some what they've done, no? So, all right. Now I think I was going to, yeah. So I think this is one of the very first ones that I submitted. No, this one's not too cool. What can I complete? Resistor, color trio, spiral matrix. Oh, spiral matrix was way harder than I thought it was going to be. Pythagorean triplet, acronym, new. All right, let's try one of the last ones. Custom set, rational numbers. Rational numbers. Everyone can learn about rational numbers. All right, I'm going to let you guys read this one. Like, I know what this one is supposed to be, but I haven't done it yet, so we can do this one together. So just let me stretch out for a bit. I'm going to come back to it. We're going to have to implement the rational numbers Julia style, so that's going to be pretty cool. So you'll get to see me do all the mistakes as I attack this problem. Be right back. All right, gang, we are back. I just remembered I can post the stream to somewhere else. Let's do that. All right, we're back. So you're going to see my full workflow as I stumble into all the possible problems one could have with all of these things, right? So let's do this. Play your pump up music. No, get ready. So we've read the problem. We need to implement the absolute value, the sum, the difference, the product, the division, the exponentiation in many different cases. There we go. Implement the following blah blah blah. Absolute value. Implementation of rational should always be reduced to lowest terms. For example, blah blah blah. To reduce a rational number R1, divide it by the greatest common denominator of A and B. So it can be assumed that the programming language you are using does not have implementation of rational numbers. All right. So what we do is we read it, we gain confidence, we go off, we cry because we don't know what we do, we panic. After we panic, we try to write things down, collect our thoughts, and then we hit it. So this is what it looks like. We set up our screens, CD rational numbers. Nope, don't have it yet. So I'm just going to download it. This software is what you use from their webpage. You just download it for whatever system you have. Then you do vim rational numbers, rationalnumbers.jl, and then you're here, and then you go to rational numbers, and then you do rational numbers, and then run tests, and then all right. So hello. So it says that the first test I got to pass is that one. So let's try that. Abstract type, rational number. It's less than real. End. And then we do, we should be using revise. Are we using revise? We should be using revise. So that's not an abstract type. That is not an abstract type at all. That's a struct. And it will have T and S type parameters, and then I will have A is type of T, B is type of S. Actually, we're both gonna share type. Yeah. And then we're gonna do this is the inner constructor, rational number T, A, B is equal to, is then if B is equal to 0 of whatever its type is, this is a type generic. What is revise? Oh, revise is a package. So this is what when someone says, oh, it's something cool you can do in Julia, I just go revise JL GitHub, right? So it was written by Tim Holy. And what it will do is that because Julia is so dynamic and you have a whole lot of methods going on for different from different files, what you can do is that you can set up this package so that whenever you are working on a code, you don't want to be restarting your Julia every time that you redefine a structure or something's not defined, you want to be able to like just change your code in that file and then keep going back and forth from the terminal. So it just like really lets you like almost magically edit your code in a file and then go back to the REPL, and then the code that you edited is now the code that will be running in your REPL. So that makes it really, really, really easy to be developing Julia, no? So if you really want F, let's add it. So if you do, this is the trick that I was telling you about. If you do the edit hello, it edits up the code in your example. And then so you can just be inside the REPL and just edit anything you want with the edit macro. And then whenever something doesn't work, you just like, oh, this should work. And then if it doesn't, you just run the test, and then it's fine without restarting Julia. Because this guy, this very brave, you know, PhD in neuroscience or biology or something called Tim Holy, he got too tired of like pressing like Control D so much on his Julia that like it almost like broke his keyboard at some point. He was like, right, there's got to be a better way of doing this, no? So I think you have to do it in a module. Yeah, I think that's the only key takeaway. So let's try and do that. Module, rational numbers, and if it's 0, otherwise construct a new. No worries, Sion. That's what we're here for. So if I want to do so if I have, let's say I have 10 and 4, right? 10 and 4. If I have 10 over 4, it should really be 5 over 2. So I should look at the greatest common denominator between 10 and 4 and divide 10 by that. Ants works. And then call that an int. Yeah. So I will use a over GCD of AB and call this an int. Let's just call these ints. Yeah. Oh no, because they can be big ints. Yeah. Let's do that. B int of B, and then if I do 4 over the GCD of 10 over 4, then I should get 2. Yeah. GCD of AB. That's actually inefficient. Let's do this. D is equal to GCD of AB, and then return the new of A and D and D. Does this work? Will this work? Let's see if it works. So now I do include. Nope, that one. Oh yeah. 0. If it doesn't work, then we throw argument error. I never know how to handle errors. I've never learned that. I just hasn't been my thing yet. Maybe today's the day. Oh yeah, this has to be real. T not defined, rational numbers.jl2. Where is T not defined? Placing module syntax too few type parameters. Oh. type of A. I shouldn't be doing that. I should probably be going, oh my god. Just call them all ints. For now. Too few type parameters. So convert. What's the easiest way to get a type union? Super type. Super type of int signed. New type. Type max of int, type max of int. No, not that. How do I join types? What was the way to? Union int. Yeah. I'm probably doing something I really shouldn't be doing here. Somebody can tell me what I'm... Too many type parameters. Rational number not defined. All right, I think export rational numbers. I think the where t should make it work. Yeah, maybe. Let's try this. Rational number not defined. All right, let's try not using revise for now. We'll be fine. We'll be fine. Inexact error. Expected, so this is argument error. Oh, this is, oh my god, I remember this. This is the... Did you tweet about the stream? Ahid wants to retweet it on the Exercism account. Yeah, there's, so sasclone, there should be, I might have, it might be on my Twitter account from Brain RPG. Let me try. If you go to @razenlaunam, let me put you on chat. Streaming Exercism, completing the Juliet track on Exercism right now. All are welcome. And then, nope, that's not it. It's twitch.tv And then brain RPG, yes. That, and then let's just tag the Julia Lang people. And Viral, because he loves that, he loves those retweets. All right, that should be good. And let me share the tweet. If you wanna, I don't know how I can. This might get funky for a second. Just I don't know a better way to do this. So, brain RPG. I'm just gonna post it into chat. Oh, exercism.io. Yeah, that should be exercism.io. Yeah, there we go. Oh my God, what happened? Scary, scary. Might like this. There we go. Should be good. All right, so now everyone gets to found it. Yeah, great. Now everyone on the internet gets to watch me fail even more. Awesome. It's not a failure if you write your knowledge down. That's science, right? It's supposed to be. All right. So I claim this argument error will not spit up in my face anymore. Is it still angry? It's still angry. There was an error during testing. Oh, maybe because I've got my conditional reversed. That's silly. If it's not equal to 0, do that. If it is, do that. No exception thrown. All right, just casually. I told you guys how I hate that all tutorials start with like error handling, and I'm like just not the person interested in that at all at any point. No, I mean, yes, it should be like handled, just not at the beginning. Just not interesting when you're a beginner. Just talk to me about error handling, why like those complex systems are vital to production like later. Just don't care about error handling right now. Really don't. Just give me a second, I'm gonna fix my hair. Yeah, you have to use error handling. I know, but it's just when you're starting to get the hang of a language, it's just not that useful to know, like, oh my God, there's an error. Yes, I know, it's clearly not passing the exercises. Like, talk to me when I'm like trying to package code and like get it to other people and like interacting with like other code sources from other people. Like that's the level of complexity that you want to engage people in at. Not like, oh, how do I like process strings or like define my types? No, it's funny enough, choosing rational numbers don't have a problem with 1/0. No, because I think the IEEE spec allows for that, but there's just like numbers and computers were a mistake. They should just never have happened. Rational 0, 1 fails. What? Let's see, rational 1, 0. That works. Rational 0, 1. No, that also works. Oh yeah, scary stuff, people. We are in the NAND territory. Yeah. Don't. Yeah, right. That's the one that's not defined, and then that will just give you nope. That is clearly no. All right, let's try. Denominator cannot be 0. Rational argument error. Rational number 0, 0. Let's try and invert that, right? And A is not equal to 0. A. If both of them are not equal, then we're gonna do the robot. What's the key for the robot, dude? Robot, rocket, raster, rotating, robot. What's the emoji for robot, people? Do you know it? It's Android. I never remember this emoji. What? Devil. Horns? No, not horse. Let's just do fire. Yeah, that's our custom error handling here. Oh, I found. Oh my God, my Vim emoji plugin does work. Awesome. Robot, rocket. I don't even know how when I set this up. It's robot. It should be robot. It's not. We can try fire whenever you try to divide by 0. Clearly. Fire engine. Call the fire department when you get a nan. Right. Let's just do fire. Fire is good for now. If someone comments with a robot, we'll get to it. Yeah. Nice. Oh my God. We all know that the best code is emoji only. Like, there's no point to coding if you don't have emojis, right? We all know this. Let's file a bug report on Julia Lang. Robot emoji isn't working in the REPL. Oh, so it should be working. Oh yeah, that is worth a bug report. Just like, oh, could not complete my emojis. They do take emojis seriously. I will tell you, like, if there's one thing you should know about Julia Slack is they take their emoji game seriously. So definitely. All right. So now we need to 0 of type if x is a type of rational number t, where t. I'm just going to leave it there so that rational number 0, 1, and then that one. Or method definition, function base must. Okay, so this is something that trips up some people when you start out. What about emojis and working in the REPL? Let's file a bug report. Yeah. Oh my God, let's file a bug report. Julie Lang is then. I'm gonna post it to chat, their Slack first. Usually I like. Yeah. Hope you're enjoying it. Let's try help desk. If I can't write autocomplete the, so usually I write this here because usually someone that knows about it will just like chime in and tell me like, oh, there's actually an issue for that, or someone has already taken care of it. Oh my God, where is this? Is this a bug? And then I will try to do the robot face. That's the one. See, the community seems really big. Didn't know about that. Well, yeah, there's a lot of people there. It's very active. Check out our. Oh my God, there's people retweeting and stuff. Awesome. Yeah, go for it. Retweet all the retweets. Right? We're finding bugs in like deep down Julia emoji code. Who could have thunk it? Oh yeah, I was talking about this, right? You got to do explicit importing of stuff that's in base, because that way it's like more of a warning, so that like if you say like, I want to overload 0, and then you don't let people know, or actually I don't really know why. So there must be a better answer as to why. Zero rational number int. No method meshing. Zero rational number. Oh, because it's just a type. Has to be the type. Right? How much is more? Yeah, there's an open PR. Yeah, so that's why. If you can post a PR link on the help desk in the Slack channel, then I'd be grateful for it. We can check it out on stream that way. What's going on? Where am I? There we go. Argument error. Stack trace expression test through exception. This might be related. All right, someone posted something already. Add missing tab completion help for emoji. Oh, that was like 6 months ago and then pandemic, so did this PR stall? That's a shame. Closes such and such. Could use a test. So Steven Johnson is a rock star for a contributor to Julia, and he's really, really good at strings and numerical code. Could you take a look at this now? Very sorry for the delay. All right, so it seems people are on it, right? They might need to, like, I guess there's an update. Yeah, so someone has to check out their tests and the REPL stuff, but people are on it. So we don't need to file a bug. But it's called robot face, no? Robot face. So maybe robot face. Nope, doesn't do it. All right, someone's on it. That's great. Pass error. 10 elements. Test through exception. 0 rational number int. Oh yeah, it's only when b is 0. I should make this test the other way. If they are both equal to 0, then you throw up in their face. Not like some other corner case. All right. Oh my god, that's a lot of tests. I wish it didn't do that. Expression, test through exception. All right. Test through exception. Numbers. Plus not defined. Plus not defined. Plus not defined. All right. So let's define plus. Base function base. I think it's like this. I can't remember. X is a rational number type T, and then Y is a rational number type S, where T is a real. I'm doing this so that so I'm using the type parameters T and S because you might feed me like a big int and then a small and then just like an int32, and I want them to like hook up to the same generic type or the larger type, which would be like it would like upgrade them and convert them into the big int, right? Where T is and this is real. Yes. All right. So, oh, I should set up my getters and setters. So this is my num. Yeah, my num function takes a rational number where t is less than the real, and then the nom just gives me the a, like the nominator, and then the denominator is den will be the b, right? And so now I get to be all funky with these. Nominator, or rather the new nominator, or how do I do this? Rational number of type. How do I join types? Oh, I can't remember how to join types. I feel like a bad Julian. Convert. It's not convert. It's join. It's not join. Type join. There you go. Type join. X is the type join of t and s, and so I will return a rational number of type x. So let's check that this actually works. Type join of int and big int signed. Oh lordy. Now we're stuff from which they both inherit. Let's try this. So if I do type join int 32 int, this is really not the way to do this, but so a rational int 32 should like upgrade or be converted to a int 64 if you add it with a rational number that's a int 64, right? Maybe I'll just write those conversions. Or it's promote. That's the one. Promote. So, and there's a promote type. And there's a promote rule. Yeah, so that's what we got to do. We got to add in some promote rules. To use promote type. Yeah, so that's the one. So I want to be able to write something like do I need to use promote type int 32 int 64? Yeah, that's the one. So I want to be able to write promote rule rational number int 32. Oh, this might in 64. Let's say that this works. Let's try this out. And 64. It's not a valid function. I don't know how to do that. I'll leave that till later. Somebody will chime in probably. Yes, Sasha, thank you for your comment. Something like that. promote rule. Oh, that might actually already exist then. Promote type of int and big int. Oh, it already works. Yeah. Promote type. That's the one. So I don't need to write it at all. Yay. And then we do nom of x plus nom of y. Oh my god, no. I need to make sure that their nominators and denominators match. How do I do this? Basic maths. Hold up. I need a pen and paper. No shame in writing down some calculations. Let's say that we have 3/7. Oh. If we have 3/7 plus 4/5. Yeah, let's go with that. 3/7 plus 4/5. If the denominator, all right, let's do a fast path. If denominator is common, let's say it's shared. If den of x is equal to den of y, and then plus minus their respective signs, right? Oh, so this should be it should be the absolute values. Oh, really? Oh, this one should be the... No, let's leave it for now. Absolute values might come back to bite us in the butt, but it's fine. If their denominators match, just add their denominators. And then the denominator of x. Sure. If they do not, else if they don't, I don't know what happens if they don't. Else denominator shared. You need to find the common denominator. That's least common multiple of 3 and 2. 6! Fantastic! If you don't want to drive these yourself, the exercise readme has all the arithmetic formulas. Oh! Would you look at that? Are you saying that reading the instruction helps? Classic me. A1 over absolute value R of rational number is, let's do absolute value first. Classic me. Absolute value of absolute value of x nom of x, nom of y, denominator of x. Yeah. the sum is do I just like always do that? No fast path? If it works, it works. Let's write this down. Everyone needs more Unicode instead of this A1 nonsense. Well, you're free to make a pull request, but yes, I agree. Rational number x and so this is the denominator of x times the denominator of y plus the denominator of y times the no, that's the denominator of x, and then the denominator of x times the denominator of y. What do you think, boys and gals, ladies and gentlemen, for our non-binary friends? Expected equals line 16. Line 16. What? Oh, I'm an idiot. Function-based apps must be explicitly imported. We know that. Expected end in definition of function base. Line 18. Is there not an end? Does it need that? I think so. Yeah. So many errors, God. Oh yeah. That's why. Let's write that down. Or, yeah, I need to write that down. Right. So that there we go. Wait, I need to go back. That's a lot of tests. It's a lot of tests. No method matching net rational number. See, I never know when to like actually write the type, or like when I'm doing the type signatures for the functions, when it's just like x is the type, or like x dot dot or colon colon the type of. So I think this one has to be just because it's just because of the way they've written the tests, I think. No, it did not seem to work. Let's try and do that one. I think that's the first one to fail, so rational number 1, 2, that works. Plus, if you don't use t within the function body, you usually don't need it. Yeah, sure. 2, 3. Promotion of types rational number failed to change any arguments. Oh. So it's a mistake. So does it not end up using big ints? Not that many. All right, so we just use, I think it's fine if we just use ints here. Or rather, we don't need to suppose that they're different. That works. That does not work. Why? Did I not save it? Rerun my tests. Failed to change any arguments. That's weird. Same type error. Alright, but I can definitely do the absolute value of rational number 2 minus 3. Alright, so it's not, nope, that doesn't work. But I can try. That one works. That one doesn't. That one does. This is weird. It's because I didn't define this. Fail to change any arguments. Promote. I might have to exit my Julia here. Self-care concha time. This is weird. That looks more like it. Oh yeah, I don't need this. T here. Do I? Too few type parameters. Oh yeah. I don't need this one either. Yay, couldn't. Oh wait, I might. T not defined. This is a lot of tests to go wrong. Oh, there we go. Oh. Test through exception. Plus not defined for rational number int 64. Plus not defined? I thought it... So we have this, that works. But that does not. So usually see, this is the part where you just gotta like try and keep your head together because you're being an idiot for way too long. Very much on brand. Oh, I think I copied down the formula wrong. Alright. You made me want to go and solve exercises too. I'm finishing the Dart track. Thanks for the stream. Thanks for hanging out, Sion. Have fun with Dart. Not as cool as Julia, but you go do you. Nah, go learn whatever's fun. Hope everyone's safe during the quarantine. Take care. Bye. All right. Yes, I don't know how to copy formulas. Denominator. Oh no. Oh, I'm an idiot. Denominator times denominator plus the denominator, oh, the denominator of y, that's the one. Oh my god, wait. Yeah, the denominator of y times the denominator of x. Yes. Denominator of y, no, of x times denominator of y, sure, plus denominator of y, no, denominator of y. Times the denominator of x. Denominator of x. And then multiply the denominators. Alright. Ah. Dum-dums. So do I know how to add rational numbers now? I do not. Why is this not working? I'm doing something really silly. And I don't know why. least that one works. All right, that clearly does not work. Rational number 2/3 plus rational number 2/3. Why does that work then? All right, let's try 1/2. Oh, that works. God damn it. Addition passes. Am I just being silly and not looking at the right one? Oh, it's subtraction that doesn't work. Here's a super hack for subtraction. Function base subtraction. X is a rational number. Y is a rational number. And change around word. And this is defined as x plus rational number of the denominator minus the denominator of y and then the denominator of y. Ta-da! Now all the subtraction ones work. Great. Multiplication. This one's just, I know this one. All right. Speeding up. Rational number of the denominator of x times the denominator of y, and then the denominator of x times the denominator of y. All right, multiplication, even exponentiation works. Sweet, multiple dispatcher work. Exponentiation of a real number to a rational number. Oh Lord. Exponentiation of a, so this is one of the big Julia lessons that you don't like get it until like you've been coding in it and like actually working on projects. If you're not getting a lot of stuff for free, you're not using Julia to its fullest potential. Like I just coded the multiplication and just naturally extended, or I just coded subtraction as like defined in terms of addition, and then all my subtraction properties worked. And then just a small thing about multiplication, and then even exponentiation worked, right? For like different cases that I didn't even plan for. So I'm getting a lot of bang for my buck with my Julia code. Like it's just like a few lines, and that's really helping me out. Just like get a lot of generic behavior with very few lines of code, and that's one of the like hallmarks of like when you're like, I'm not saying this is the best Julia code, but like if you're writing good Julia code, you're getting a lot of functions for free. You're getting a lot of bang for your buck per se. All right, and then exponentiation of a real number to a rational number. AB to a negative integer power is r to the n. So which one was it? So base, that one, x is a t, y is a real number, where t is less than real. That should give you x to the, oh, is it? Oh, it's exponentiation of a rational number. Of a real number by a rational. So I should say real rational. Does this function exist? Root. X to the denominator of x, yes, and then this is the denominator of x. I don't need that one. Where did I write real number? Ah, that's silly. Alright, of a real number to a rational number. So if I have 8 to the 4/3, how about I just do that? X to the denominator of x by denominator of x. Nope, not working. Ah, because I'm an idiot. It's the y. Yep. Pain tolerance. It's all about the pain tolerance. And psychology and not getting too down on yourself. What is division? Right division. Base, and then this is division. X is a rational number. We're almost there, Sasha. We're almost there. We're getting there. We're getting there. You know, one blunder at a time, but we're getting there. Both of these are. I'm gonna. I got the standing desk recently, so should probably try and use it. It hurts, but I recommend it. I want to do the. We're almost there. Nice to have you in chat, Sasha. Good to see you. This is all your work. Now we have video tutorials of what you started. Do I know how to do this? I think I do. So if y is not equal to 0 of y, yeah, it's great seeing you solve these. Ah, awesome. I should try and make you a moderator. I should try and make Julia people moderators, but I'll get to that. So if it's not 0, if 8, so if I already wrote down like 3 things to improve on the exercise. Oh my god. Just more pain, just adding on to the pain. It's not too bad. Like I know like this is like probably one of the more idiomatic Julia exercises that you can teach someone, like, hey, like this is how you actually can build it up yourself, and it's in the manual. It's a really good exercise to like show people like what like the actual workings of a Julia code base look like what's the kind of stuff that you worry about, like how to handle dispatch, having those accessor functions, like that's all. Like this is, I like that this is more towards the end of the track, no, where it's like you want to consolidate people's like idiomatic Julia library code building, right? So like I know the flow of like how all of this should go, and so like I know like, oh, I need a struct, I need dispatch here, and all of this stuff. But it just, you know, doing it live is a you just feel like 50 times down. The example solution is heavily based on Julia space implementation. Yeah, it's great because like you can almost come up with like the base implementation yourself. So I mean, plus minus some modulo, some like really clever optimizations. It's almost the code that's in there. No, and you get like fast performant generic, like all the poster childs, right? Denominator of y times the denominator of y. If this is equal to 0, return. What am I looking at? Ordering. Yeah, I don't know about ordering. To do at the problem spec. Yeah, I'm not gonna look at that right now. Oh, you're using numerator and denominator, absolute value, division. All right. Do I just return an error code? Sasha, are you seeing this? Like we ask for, we don't test for the case where you try to divide by 0. Are there any of that makes in the base implementation? Mostly just a lot of edge cases that the exercise doesn't care about. Yeah, I would have guessed. I was like, oh, like what if someone feeds you a nan, or some infinity somewhere, and it's just like, you know, it's good enough for like. It doesn't teach you like any more like idiomatic Julia ways of thinking. It's like problem specific implementation details. Yeah, and, oh, no test for that. All right, great. So we can just assume return, let's do argument error. Argument error divided by 0, and then we're gonna add some, what should we add? Where's the black hole? Robot. Oh, there's no robot face there. Dynamite, fireworks, alien. Yeah, let's do aliens. Divided by 0. If happens, else. Yeah, I thought of boom. I already have the fire, but I don't know. I thought of like black holes falling into the universe. Guess some aliens close enough. Else we do this. Let's do that. Let's do the short circuiting version of this. Else rational number. This sounds like it has to be the other way around. If a2 the denominator of y and then the denominator of y, yes, and then the denominator of x, yeah. Rational number of, oh my god. Hey, maybe we can tell the exercism people that like some LaTeX on the exercises could like very much improve quality of life. No? Looking at these fractions could be a daunting when it's just code. Denominator of x. I'm going to have to change all these denominators and denominators for the ones that you guys want. We could probably like move that test up like farther up so that people know it's like a little bit of a building block. And so denominator of this one and then the denominator, yeah, the denominator of the y. And then the denominator. Oh my god, I'm an idiot. I could have just inverted the. I could have called division 1 over multiplication. Because that's what it is. And this will be the denominator of y times that denominator of x. Because it's the other one, right? It's flipped. Huh. Silly me. And then that's going to fail on the nominators and denominators tests. Slash not defined. I mean, it's not defined. I literally just, oh, oops, nobody saw that. Just the entire internet forever and ever. Some tests did not pass. Three, four. Oh. Oh, this is sneaky. This is a sign issue. I think this means how did I get so weird. Alright, let's try that. One over 2 divided by and then that says that it should get, so we're going to step into the debugger, folks. Get ready. Blah. It's warming up. There we go. So there's no division by 0, and then we step into this one with S, and then we do the get property. Sure. Denominator. All right. Ah, I missed that. Yeah, this sign thing is gonna be a bit tricky, I think. Oh, man. So it should give 1, 2. Which one's the one that gets hung up on? The one where there's a single, there's 1 or 2 minus signs. What if we defined let's try that trick again. Let's try that, and then x times an irrational number of the denominator of y and then the denominator of y, and then see if that works out. Yeah, that sounds like an easier way to do it. If I'm just gonna brute force this sine minus 3, if the sine of the denominator of the result is equal to minus 1, and that is equal to the sine of the denominator of the result, then return a rational number that is minus the denominator of the result and minus the denominator minus the denominator of the result. That should fix 1, I think. Oh. Otherwise, just return the result. Yeah, that was a bit brute force, but and then the one where we have to bump up the sign. think what I can do is I can define base multiplication of a, where x is a t and then y is a rational number, so that it's a rational number of type of x times denominator of y, and then denominator of y. Yeah, that should do it, right? And then so this is a classic trick to just invert the order of the arguments that were called, so that it dispatches to like a previous definition that you had. And I'm running this to so that I can get this one. And then that should let me do this. T not defined. Yep, that was dumb. That was silly. Let's not do that then. All right, let's see. How do we handle that case? I think I just have to just hard code the sign into sign of will that flip it? That was a lot of things that did not flip, but I think it passed the ones that it had to. So let's see, let's look at the first one that did not pass. Absolute value, reduction to lowest terms, numerator, not working. All right, we're going to work some find replace magic here. Think of all the bytes you're costing me right now, Sasha. Think of the bytes. So now it's n swap and swap and swap, swap and swap and period and period and period, period and period and period and period. Oh, I could look into getting some hotkeys so that it shows up on the screen whenever I'm typing. That might be a little bit too much noise sometimes, but it could be worth it. Hello? Hello? Reduction to the lowest terms. Function-based denominator must be blah 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 blah. Denominator not defined? What do you mean not defined? 26? Oh, maybe that's silly. Did I ask for... Oh, I asked for a numerator. Oops. Oops. But denominator is, so... Thanks for catching that. Numerator. So, same deal. Nominator. Oh my god, now it's got the nominator. Next. Changing word. Numerator. Not that one. That one. Not that one. That one. Not that one. Not that one. Not that one. That one. Not. That. Not. That. That, not, that, not, that, not, that, not, that, not, that, not, that, not. Oh. I think I got quite lucky that this didn't catch a parser error. This code has a smart rename button for that. Oh, I'll look into. I've jumped between so many editors, man. I just want something that. Error method function-based numerator must be explicitly imported to be extended. So it is in base. Meh. I'm not against any. You probably want to throw the error and not return it, by the way. So what is the difference between throwing the error and returning it? That's throwing error. I wish I knew of like a handy like tutorial or explanation of like why all the Julia exceptions or shenanigans. Like it's not even Julia, it's like exceptions and error handling is hard. Like Rust has a hard time with it. Julia does, C++ does. I don't know, like there's a lot of like performance time penalty if you ever like panic and stuff like that, but I've just never known what that's been about. Numerator R evaluated to 1. Should be -1. 79. Oh, we gotta be fancy with this. It's not enough to just be. So sign of returning returns an instance of argument error, just like returns some type of return. throw does some extra stuff, like interrupting the function. Okay, so it's like good cleanup practice to get that stuff through. These numerators and denominators. All right, the numerator of that number is, and the denominator, oh, it should reduce first, doesn't it? Shouldn't it? If you return it, I think try except can't handle it either. Oh, so that's pretty bad then. So let's write that down. 40. Remember to throw your error so that catch, try, can help handle it. Yeah, I barely use it either. Someone will probably like come along and correct us. So if you write it down, a nerd on the internet just like comes right down, just like, no, that's wrong. Or someone's like, hey, you probably should know that this does or doesn't work. So that's helpful. Let me try. I gotta reduce this first. So the sign is passed on to the or rather, let's check first what that thing does. Rational number of 3 minus 9 is 1 minus 3. And we would like that to be minus 1, 3. I think so. Do I just like hack this around on the numerator code? It's like how the Jumla says it, don't overuse try-catch. It is better to avoid errors than to rely on catching them. Yeah, I know that like for Python people, they're just like, no, just use try-catch as like your control flow. And I'm like, nope, that's like clearly not the way to do things. Like I know very little about this, but I know that a lot of people just facepalm when they know that they teach people control flow that way. Alright, I think this has to be a bit fancier. Get the greatest common denominator. Alright. And then I'm going to check the signs here. Maybe there's someone on emoji symbols. What's the case that I want to handle? I want to handle it so that this becomes that. So if they have different symbols, if sign of A is not equal to the sign of B, then let's do it like this. return, rather, if the signs are equal, then just return the new one. Just do A and B. Yeah. Otherwise, return minus A, B. That should do it, I think. Oh no, I lost my stream. Blah 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 is not a valid function argument name. Where? Dearest Lord. How about we do X and Y? Will that make you happy? Global method definition around blah needs to be placed at the top level. Why is it a global method definition? Number 16. Oh, because I'm being silly. Never mind. New, not defined. Where? What a strange error, wasn't it? I don't even remember what it was. It was so strange. Global method definition. That's so weird. Never got that before. I guess Julia does not like incomplete functions. New, not defined. How is this not defined? New, not defined. All right, let's try an explicit return. Oh, maybe it's that. It's so weird. You got an extra at the end there. I got an extra colon between new and whoops. Yes, that's a funky one. All right, let's try and do that. Maybe it's going to be good. Well spotted, sir. Ain't no debugging like chat debugging. Thanks a lot. Now we're back to this one. We can't add numbers now. Fantastic. All right, let's just, what did I break? If their signs are equal, return the, I should do the absolute value here. if they're not, just return the absolute value of x. I think that might work. Denominator. Okay, we're all the way back to denominators again. R3, line 80. So it's that one. Dear God. Oh, and fix this. Oh my God, that's a lot. That's a lot. Oh, that's a lot of things that are not implemented. Dear Lord. It's just, that's a lot of tests you wrote there, Sasha. What? Oh my God, 94. Oh my God, you're just, that was not kind. 94,000 test cases. Let's see. To do, add the problem spec. A rational number equal for all of those numbers, test that it's implemented. Then such a thing is implemented. All right. So there's no need. Let's clean this up a bit. There's no need to promote. You can get rid of that. Do I need this? Nope, I don't need it. Yeah, I don't need it, so we're getting rid of it. Whoops. Yeah, I know. I saw the loop earlier and I was like, oh, that is a lot of tests. Damn. All right, let's try and do this. So ordering, I need to define equals. So I need to do base dot is equal for x, rational number, y, rational number, right? And then this is equal to denominator of x is equal to the numerator. It's now a numerator. The numerator of x is equal to the numerator of y, and the denominator of x is equal to the denominator of y. So I also need to have is less than and greater than implemented. I get it, I think. All right, see you soon, dude. No. I think I should define is less. Is this the generic one? Yeah, so if I implement, I think it's, I'll try this. You could use the zero method for this. Yes, that's much smarter. That way I don't need to define all this stuff. Wait, give me a second. Stream's been going for almost 4 hours. Give me a second. I can just do this, no? If the denominator. Should be enough. Oh my god. Sasha, so many tests. Let's see. Oh, I'm comparing them to my rationals to reals. It's a bit silly. So did I just go and become a little too extra? Base. Ah. Didn't know I had to define this for all functions. I thought it could be, oh no, that makes sense. I think some of these are not needed, but it's too late now. Where? Do I need to add the a lot of tests. You know, it'd be easier if maybe there was just a little bit less tests to, like, maybe not have to like scroll infinitely through 50,000 lines of history generated. Oh God. Where'd it go? There's a way to like pipe this to a... Oh my God, I hate that. I hate pipe. I might have to do that. There we go. Oh. Look at that. Look at how many. Have I been using the wrong... Oh, I think so. Oh my God, yeah, this is stupidly wrong. This is so not the case. Guys, my brain's getting real poop here. I'm gonna have to maybe take a break. Yeah, I think I'll come back to this after I eat and I shower. But we're on the final battery of tests and I'm doing something really silly. So, and then the show one is gonna be like a pretty easy implementation. It's not, yeah, I'll show you. I had to do one like this before. It's not too bad, but I think I'm gonna call it a stream for now, and I'll be back in like maybe an hour or two to like stream the end of this and then go on to the robot directions, the Martian robot rover problem. All right, it's been a blast. See you guys soon. I gotta go get some food.